Start recording. Okay. So last week we had this guy running. Now, did you end up getting the code for the... if you scroll down, I pasted you a copy of the code that we used.
No, I don't think I did.
Okay, so I think the only thing you were missing was the thing that said, like, if you have a little circle and a huge circle, we'll make the little circle move more. So we should probably just put that in because I think that's worth having. And it's not too tricky, so there's more or less this bit here. So yeah, you're divvying up the available thing by half, and we decided rather we'll stick in this sort of toy mass equation saying that bigger circles are heavier. And I mean, we could have A, B, and B density, but for now we'll just say they're both 1. So it's basically the formula for the area of a circle, which we looked up on Wikipedia because we're professional geometrists.
All right, just give me 1 second. Hopefully it's not too noisy.
Oh, go for it. Can't be any louder than my keyboard.
We're really close to the microphone because I'm in the hotel, so I'm using a laptop keyboard for the first time. Good. And A move and B move is separation times relative opposite.
So I think that's worth having because yeah, I might lay out mine the same as yours actually. There we go.
Yours is calling circle then arrow.
Oh, that too. Yeah, no, I moved my separation value down closer to where it's used. So hopefully yours works.
Oops, hold on.
Looks pretty good to me.
Yep, I'm liking it.
All right, excellent. So, what we were doing... Okay, so we've just... we've got this, I think it's about 40 lines of code. Most of it's drawing and like temporary values and stuff. And it just draws these for 2 circles. What we want to do now is something like this. So we'll scroll up to the update function. And something, oh, this is starting to really bug me. I'm gonna fix that in the template because no one likes doing it this way. But if key down space, I think space is reasonable for now. Let's call it do separation. And so today's effort is we are going to try and implement do separation. And this is going to be one of these ones where I'm like, okay, I'm going to hand over the coding duties to you, Daniel, and we'll just see what you do about implementing this function. It should be fairly easy because we've got all the maths and we just have to apply it now for something other than drawing.
Do separation. So you mean to move the circles by the amounts that we've drawn are the places we want to go?
Yep. So for 2 circles, we'll get these like the 2 black circles will be the circles after we run that function. And if we have like a whole bunch of circles, we'll get something reasonably useful out the other end.
Oh, I see.
So it's basically iterate all of the circles and apply our function, and then we will we will do another step after that.
Okay. Well, okay. So this will probably be the first thing I do. Oh, good. We're close to the method.
Oh, that's right. We've
Yeah, I don't think we want to. Like, I think you're saying we're not going to limit ourselves to just 2 circles now.
Yes. It's like, oh yes, we do have this iteration here. So this is basically just going to be copying and pasting for the most part.
Yeah.
Makes life easy.
So now we have circle I and circle J. Well, A and B is fine. Would be the 2 circles that we care about. And let me see. We got our and we got our hats and our thicknesses and so on.
Thickness is probably.
Well, hold on a second. I'm gonna paste a bit and then remove a lot more probably.
I was thinking that's probably more efficient if we just grab the whole shebang and then start chopping it up.
So I'll keep A, B, N, and P. Excuse me. And thickness. Well, probably not, because I'm just going to move the arrow, so that's gone. And anyone who cares about it is gone also. So that's fine. And then I'll probably keep remove the line batches. I'll keep A start possibly, and B end maybe, not yet, sure. Keep our toy mask. Keep our intersection, clearly. So, okay, so we do separation. So in the event that these two, I'm totally wondering about what happens when these circles just don't happen to be like circle 4 intersects with circle 9. Well, I'm gonna worry about that later, I guess. So mass, it's fine. So A move and B move. Excuse me. So that's how much that A needs to move and B needs to move. So let's say, okay, so circle A position.
Now, before you go too far, remember that circle A is a struct, so you are working on a copy.
Correct. So I need to reassign.
In fact, that's a list, so you will actually have to work on the copy and then reassign it into the thing.
Oh, fair enough. Okay. So I'll do some stuff and then I'll...
This is one of the things that's annoying about C#, because if that was an array, you could certainly go circles I dot position equals n, and that, in theory, I think that's going to give me an error. It's going to give me an error in this. Cannot modify the return value of systems generic collections generic list, blah blah blah. This int here because it is not a variable. Because this getter thing. And so you have to do this reassignment nonsense. That's one reason if you saw the code for a lot of the physics stuff in River City, rather than using list, I was just using an array and a count on its own, and that way I could just write directly into the array.
That's right, I remember that.
But for now we can do it this way. We'll worry about data layout stuff another day.
Right. Now I'm directly, of course, at the spot where I don't want to do a thing that I'm already kind of sort of famous for doing, which is messing with the circle's position components. Because we have a position and it's a vector. I want to move it by some amount, but because we were on a number line, because we made it into a number line, A move and B move really are talking about what are they talking about? Are they talking about x-axis or are they talking about uniform?
Well,
transform?
I mean, we wrote the code that draws out exactly what they're doing. So I mean, we have circle
Yeah.
A and circle B,
Right.
and so I mean we can scroll. Whoops.
Yeah, but I mean,
Scroll the window. We can scroll down to that and be like, well, a move is gonna, it's gonna draw an arrow, and it's gonna draw a circle, and
yeah. Okay. Okay. Right. I'll grab these again. I guess.
I mean that's not a bad plan. Just to
I need
study
to.
them.
If I don't have hats, then it's just not right.
Well, you're on the
Gotta
right
have
track
my
by
hat.
saying that you need hats, because yes, that
I
is
gotta
true.
have my hats. So I need to I need to scale the position by the amount that I need to scale my position vector by the um by the scale of n hat to a and n hat to b.
Not quite. You need to add to the position vector, because if you recall, the position vector is a vector from like the origin, which maybe is up here,
Oh right.
going to
Yeah.
there.
Oh, yeah, I have to add it, right. Okay. So
So scaling it sends it out there. Adding it, on the other hand, we can add on something else that we might scale.
yeah, well in this case A is circle A position and then I'm just adding this on top.
Seems pretty reasonable to me.
And then same doing for the other guy except with different letters. This goes here. Oops. This goes here. Let's go away. Hold on. Yeah. I'm not dealing with display properties. I kind of want to say I'm done for now. I mean, I could remove some stuff, I guess. Be economical, but
Oh yeah, well we're not using the perpendicular, and oh you're quite right, we're not even using the we're not using start and end of A and B. Fancy that, we're not. Oh well,
I don't know. We'll see how
that
it
seems
goes.
pretty reasonable. Let's run it. We can.
Forgot to do something, didn't I?
Did you?
Didn't do anything. Or it did do something, and I'm just looking at the weird drawing stuff. Maybe I should comment out some of my drawing.
Well, recall
Not
what
sure.
recall what we've done. I mean, this takes all of the circles, and when you hit space, it separates them. So if you hit space,
Oh, I forgot to press space. Okay. Right. So here's the gray images or the gray circles tell me where I want to go. Pressing space, and then they just go there.
that looks pretty great to me. So what happens if we draw a whole bunch of circles?
Yeah, that's the thing I'm worried about, especially if they end up back on other circles that don't necessarily aren't the same ones that they're overlapping with in sequence. So sure, doesn't work because
Well,
I haven't.
mm,
I mean, yours is pretty.
that's
Mine
because
isn't
I
pretty.
mashed
Yours.
this. Sorry, that's because I mashed the spacebar.
Oh, interesting.
Yes. So what's
I don't
happening?
actually know why that works.
Well, let's have a little think about why that's happening. Because I mean, we're iterating through these circles, and they're separating from each other, but they might be separating in opposite directions. So if I have, let's try and do this. In fact, let me comment out the drawing code for a bit, so we're not. Constantly looking at the arrows. So let's try and set up a simple system. What happens if I draw that like so? And if I hit space, you'll see one separates successfully, but this one over here doesn't. And then I have to do that because this is separating into that one, which is separating off over to the side, and so on.
Right.
Now if I draw this, That seems to work. We'll draw this one last. So you can see we've got a little bit of a issue when we've got massive quantities of overlap. So there is one thing that I want to do to this that's going to sort of be a recurring theme where we do the physics stuff. And you might have seen some of this when we were doing River City. And that is, you'll notice that if I 1, 2, 3, it separates out one and then the other. And then if I do 1, 2, 3, it does the same thing. But it's basically order dependent.
That's right.
Which is often a property you don't want to have in a physics simulation. So what we want to do is, if I go to the whiteboard, we've got all our circles here and maybe they're overlapping and so on. We want to basically go down into like a list of how much to separate each circle by. So, some of them will be like circle 0 goes that much, circle 2, well, circle 1 might go that much, but then another thing might come along and separate it that much. So we get like the addition of those two things, which would be like that much. And so on. So, normally they'll just get the separation amount, but if you've got two things separating a single entry, they get added up and applied all at once in a separate step. Because what's happening here is we're going, we're doing that thing with the grid, and we're like, we'll take, if this is 0, 1, 2 versus 0, 1, 2, it's like we'll take 0, that one, then we'll take that one, then we'll take that one, and so on. You get this like diagonal effect where you're doing it like that. And so this last guy here is looking at a very, very different view on the world than the one we did up in this corner, because all of the circles have moved around. Whereas if we do it this way, everyone is looking at the same view on the world. Now, usually that's a nice property to have. So let's see what happens when we implement that, hey? Does that make sense?
Well, yeah, I mean, sure. I'm just trying to sort it out here. So basically you want to, yeah, we're not going to apply this anymore here. We're going to create instructions, I guess, to apply it after we've made a pass through. Although I don't recall in River City, I don't think we had like a full phased update, right? Because like sometimes we had situations where like a fist would win because it was last or something like that. But what do you think about it?
For combat, we did. I think. I think for combat and like, user interaction stuff, all of the state machine stuff, that was obviously phased, because kind of there's no other way of doing that. It just gets too complicated, and there's not this mass interaction. But for physics, it definitely was phased, and it ended up being very important. Also some of the AI stuff as well, I think, because it's that kind of massive, n squared thing where it's like everything looks at every other thing.
Right.
So when it went to like query a position, it stored like the position at the start of the frame, and so on. And yeah, it actually did several phases. And they were kind of, it's like, that doesn't work if you don't phase it, so we'll make it phased.
I don't expect to keep this. I'm just working it out. I assume that when I'm like, I wouldn't. I don't never want to do it this way. I don't think. But I'm kind of like looking at this like is pseudocode and
That's all right. I'll let you keep coding that and see where it goes. So hopefully you can already see why I use arrays rather than lists.
yeah, I mean, I'm like, well, this isn't great. I mean, I know I've got what I've got my calculations there, and then I want to pull them out and go 2 circles at a time. It's like I don't really want to go through the whole loop twice, though. But, hey, what it is.
So what I want to point out before you go too far down this road is the thing that you're doing. You've got these. I don't have them in my code, but you've got these add to this boo list here. That's inside one iterating loop, then the sub iteration, and then a conditional.
Oh, poop! Yeah.
So basically, I'm saying the approach you'll take is not going to work.
Oh, I know. And then add 0 to it's not my favorite. It's just what I'm just gonna stop all behind. The only thing I know for sure is I want to defer this. That's it. So I guess I could. I don't know. Keep the copies of the circles around.
Well, in fact, why don't we do this in another order? Like I've been saying, no one likes the lists. Let's convert these to arrays straight up. Let's back out that code change. We'll get rid of boo for now. And so this one here, rather than adding it to the boo list, it was just circle a dot position plus equals blah blah blah. Just here, we'll back that out, and we'll do this in 2 steps because this is actually quite useful to know. So, yes, let's get rid of circle list and change that to circle array circles equals new equals something, and you're going to need some kind of count. So over to you.
Well, I don't quite understand. You've got an array of circles and a list of circles.
Oh yeah, so we're getting rid of that. But the array is not. So you'll have to remember, the list has both an internal array and an internal count. So we also need.
I don't know. It seems kind of like I'm gonna have to keep resizing my array. Isn't that kind of a bad thing?
Well, it's. I wouldn't call it a bad thing, but yes, you have to ensure that you have sufficient size in the array. So, in a certain sense, we're doing our own re-implementation of list circle. So, I don't know whether this is like something you've done in school or something. Like, have you ever implemented list before?
Yeah, I believe so.
Yeah.
I mean, I get that you want to start at a particular capacity and you want to increase it by by 2 times what your incrementer is while you're trying to find space for stuff and blah blah blah. But yeah, it's been a while. So okay, circle. So we'll have space for 10 in there for now. Oh boy.
Where'd you put the load content? Okay.
Now I have to have it. Don't I now also have to include an index or where I am in the thing?
Well, that's I mean, we can get out ye olde whiteboard and have a look. So if we have a poorly drawn list, in fact, if we have an array of, what have I got there? Let's say there's now 8 elements in this array, and we've filled up 1, 2, 3, 4 of them. Those are at positions like index 0, 1, 2, 3. The number of things we have in the array, so the count, is going to be 4. And
right.
As you can see, that also points to the end of the the next available slot for inserting something.
I remember now, yeah.
So that's why zero-based indexing is handy, because it's like the count is the same thing as the insertion position.
Right. That's that, and then that's just length now. Although.
Or is it?
Oh, right. As length is 1 based. This is one count is 1 based and length is not.
No, they're both zero. No, yeah,
No,
they're both 1 based, but they're not really an index. They're not really based at all.
Right.
But the length.
Well, whatever. I find re-implementing a list kind of silly, but I'm gonna do it anyway.
Trust me, you're going to need to get used to this code. So that's
count / length.
That's array length. This is circle count.
Sure.
So you need to manage both of them.
Mm-hmm.
But you also have to make sure you have the right one.
All right. So for clear, I don't know if we're just doing this kind of thing here.
Well, so this is where it's handy to think about storage, because it's like, because this is like, we're not securing data or anything, we don't actually have to go through our array and zero out these slots, because what clear does is it goes through the array and it's like sets, it's like set that to 0, set that to 0, set that to 0, set that to 0, la 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 la, all the way through the array. I mean, well,
or you can just set the number. You can just set the fact that your count is a certain thing, and then you can just leave them in there, right? Like a hard drive
you should
data.
be like count equals 0.
Okay.
So
that seems preferable.
There's your clear.
Well, I don't even think I think the real list does something more heavy-fisted than that.
The real list has to do that because we'll have a little aside on the intricacies of the C# of the .NET runtime. The struct that you insert into your array, if this is an array of, that's not how you draw an array. If this is like a foo array, and foo is like struct foo. In fact, oh my god, what happened there? Foo, and it's like it's got bar B in it, and bar is class bar. What you have here is a reference. Now, when the garbage collector comes along, it's going to be like, oh, I don't know anything about this count here, so I'm going to go look into like this element of the array, which is, not something useful. And I'm going to see this old reference, and I'm going to keep this object, I'm going to mark that object as in use when really it's not. So what happens if you don't actually clear it is all of these fellas get marked as usable by the garbage collector. So if you have a huge one of these, you could potentially be wasting a lot of RAM due to garbage collection. And in fact, I don't think you need, like, this could just be just bar array and referencing into that. I don't think you even need the intermediary struct. So
I know that we literally do that in River City where we just set we try to make an ON list, right, or a O1 list clear somewhere in,
I'm trying to think
for a
about.
reason. I can't remember why. Whereas the list has an ON clear because it does have to go and kill the references. Although I don't know why they don't use like a weak reference or something instead. Couldn't they do that?
No, because the problem is, I guess, the problem is at some point you have to iterate that list and clear out those and clear out those references. I mean, they could, in theory, add a thing to the garbage collector that was aware of the.
Oops.
So that looks interesting. So the first question is...
I forgot to increment the circle count somewhere.
Click on circles count and find references and see what happens.
Well, sorry, circle count for sure. Something up there. Yeah, there's no plus plus in this. Perhaps one should increment the count when one is adding. I bet you could do that fun thing. I forget which one it is, but I think it's this one.
Yeah, I never do that because it's not worth the headache of like, what's it doing?
Yeah, okay. Good point. Far better to be readable than clever.
Circles.
Although, it's still I've kind of ruined everything in some ways here. Yay! Complete mess. Okay, so what did I do wrong here? So, making a new circle. That looks okay, I guess.
Well,
actually, wouldn't I wanna add one first?
No, because it is the insertion point. So if
that's right.
Yeah.
Right, yeah. So okay, so I'm gonna call this good. The weird one is like when I hit escape, I'm expecting my circles to go away, but all I've done is set this.
Well, I mean, let's go look at the drawing code that we're using to draw that.
Well, yeah, that's just it. The drawing code is not respecting the circle count. The drawing count is merely iterating the array, which has all a bunch of stale stuff in it. So, perhaps I should just be using the circle count.
That's all right. That's easy to use. Where is that code?
We'll do that again down in the draw. Where is that here? All right. And circle length is greater than 2. Let's just remove and abolish that forever. In fact, let me just I'm going to look for usages to make sure. Oh, well, yeah, not in FNA, clearly. Let's make sure I'm using your circle count is greater than 0. In fact, circle length is maybe no. Yeah, definitely not really wrong. Circle length. Here. Let me see if I've done anything to help myself. That looks a lot more like it used to. Pressing escape still is no good yet, so...
Well, it got rid of the lines, but this is one of the tricky ones, and that is this little sucker here. Because this is what's actually drawing our circles.
Oh yeah, there's yet another iteration of the array. Okay, well I'll just convert this to a for loop and add circle count, I guess. Nope. Hold on. What did you?
That was interesting. I'm surprised that didn't work. So,
Well, maybe it got in a weird state or something. Yeah, I don't know what happened there, but that's fine. And then separation code should still. Okay, so where we were before, but there's no list.
okay,
All right.
well, now before we go too nuts, let's scroll up to load content. What's your load content look like? Okay, so circles equals 10. So possibly you did this while I wasn't looking, but why have I got build errors?
Oh yeah, we haven't resized or downsized, or we have resized this array.
Yes. So 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.
Boom.
Ah,
Yeah.
there it goes. Index out of range exception.
Right, of course. Okay, so that shouldn't be that should be easy to just find the adding code somewhere in somewhere in update. Okay, so where are we? Okay, creating a new circle, adding a new circle. Now say if circle count greater than. We don't have an array for this, but that's fine. I don't know constant blah blah blah. It's great. Sorry, this is wrong. If we've now officially added our 10th circle, sorry. I don't know if this is whatever. If we've just added our 10th circle, then I would like, or no, this can't even be 10 because that's just going to be, and I'm always going to be adding. Okay, so what is it? There must be a capacity here. So if the circle count is also equal to the circle length, then we need to extend. If I've just added enough to fill the array, I need to extend the array. Now this is the part where I think I'm not sure if I use one of these guys or not.
So this is just API bollocks. So I'll just be like array dot resize.
There we go. Alright, so the original array is circles. The new size is, let's say, circle count times 2 and grow it. Double it. Yeah. Okay. I don't think I want to do anything more than that.
So that's not bad. That's like, that'll work.
Right.
But we could be better. We could be slightly better.
Okay.
So if we look at, let's stop that. What is that doing? So let's say we've just got an array of size 2. So it's like 1, it's like 0, 2, 0, 1, and the length is 2. And, so we're going to add 1. So we've stuck a thing in here. And so count equals 1. And then we're going to stick a thing in here. Count equals 2. And as soon as that happens, we've triggered a condition where we end up going here, 2, 3, 4, 4, and then we have an array that looks like this. Now, what we could do, well, I mean, what we're saying is, okay, now I go ahead and for example, we deleted that element, or we cleared the whole array or something, and maybe we add another one and so on, but this is all we ever do. What we've done is we've just allocated all of this space that we're not actually using. So what we should do is, rather than after we try and insert that one, we should be trying to expand it right before we go to insert, say, this one here. So basically it's a reordering of the code, and that just makes it a tiny bit more efficient.
Yeah, I can see why. Okay. So I will say that if it's about to be the last one, we'll do that. Do we need to resize down as well?
Usually it's not worth doing.
Yeah. Okay.
Like if you're working on, I don't know, video editing software or something, then maybe, because it's like, oh, the user loaded a gigabyte of stuff. Oh, they didn't mean to and deleted it. Let's free up that gigabyte of space to use for something else.
Right, but we're not building a framework and we're not working with millions of circles, so we'll be okay for now.
Yes, I'm pretty sure that the standard library doesn't do that, for example. So the only other thing is obviously, at this point, circles.count is now that. So we're not actually doubling the capacity. So all we have to do is just flip that to that and we're done.
Oh, right. Yeah, I just assumed they were equal in the last check, but they're not anymore.
Mm-hmm.
Wait. Yeah.
Yeah, other way.
Yeah. There. Okay.
That's looking pretty good.
All right.
I think that's everything.
Well, we still have to do the thing we're actually trying to accomplish.
This is true.
Which is not do the separation every step. So, yeah, no more list, and hopefully this will make it now easier to work with.
I'm just going to scroll down to here and change my circles count greater than or equal to 2 to is exactly equal to 2, so we don't have those lines everywhere.
Oh, good point.
So now we have an array, which is quite nice.
Okay. So.
I'm just trying to think. The only thing I might say about this is this bit of code here is sometimes nice to have in a separate method. But seeing as we're only adding stuff in this one place for now, I'm just going to say we'll just leave it. But obviously, yeah, like normally we've got lists doing all of this nonsense for us. And so it's all safely put away. But you can imagine, say, if I'm like adding a thing, is when I hit space, I want, like a new circle here. And then I do something different with that, which is what we're probably going to do shortly. And I forget to insert the resize like twice, for example. So, I didn't quite finish that. So maybe undo that add circle thing. Because what you want less so than add circle, because maybe we're doing something other than adding a circle, is ensure capacity. So like this bit of code might be called, circles ensure capacity. And I don't think we'll do that just yet. I think we'll leave it as is, but I just wanted to sort of raise that, because if you end up having 2 copies of this code, that's where it starts to get hairy. I mean, that's kind of the case in all cases, if you know what I mean. Like, in all scenarios where you have duplicated code, if it gets too far away from each other, you can get sort of nonsense. But this one in particular is bad if you end up having like multiple arrays, which is what we're going to do. So we wanted to be doing this business.
Yeah, and I don't know how to get away with doing this with less than 2 arrays, because one of them I don't want to touch till I'm already done. So I kind of just want to make another one just like circle separation, or I don't know. Well, I don't even want to call it circle because I just want the vectors, right?
Exactly. So basically what we were aiming for is, now we've got, this is our circles. Now we want a parallel array, like pending separation. that's like the same structure and the same, same capacity and the same length, but separate data. Well,
Yeah. So I think I want to. I now see that. Yeah. So in order to do that reasonably, then I'm going to want to kind of follow the circle manipulations and do the same thing with the pending separations, so that the pending separations always is the right size to be able to separate every circle in the pass. So it seems like I'm going to want to go with it.
So this is one reason I was a little bit eyebrow raising at moving this over here, because we're starting to spread out the code more than it needs to be.
Yeah, I hear what you're saying. So I'm gonna move it out of there.
I just usually just be like, why not just do it here?
Okay, done. Okay, so I'm just gonna find wherever I'm using my circles and make sure I'm resizes. So they're immediately got to do this for both.
So when you do this a lot, you kind of get a feel for how you should lay this out such that such that like this all makes sense, and you're not going to miss any instance of it. And basically because you're manually managing, like keeping these things in sync, you sort of get a feel for how to do it in such a way that you don't miss anything. And so far this is not too shabby. This is actually, pretty close to what we want to do.
Yeah, I don't think I certainly don't need to make an empty vector here, so I'm going to leave that. And then the circle count can be the index. I don't need another index for that. So I don't need to do anything else there. Let me think about, so if I'm removing circle count, I don't have to do anything else also here.
Mm-hmm.
So I may be done with worrying about the size of it. And then,
Yep.
yeah. So why don't I now just instead of putting it here, I'm going to put it into here. Mm-hmm.
Well, recall we don't have to pull those out anymore. We can just hit them directly because we've turned it into an array.
Of course.
So we could just do circles I dot position equals or plus equals.
Oh, mouse. Okay.
And let's see.
Okay, so yeah. Let's see what happens.
Not quite. Nearly. Nearly. We've got a few bugs.
Okay. Well, fair enough.
Try it with
Yeah, we're kind of
like.
like moving it by the maximal amount that it could move.
Well, try it with two circles. Like put two circles down rather than everything. And what happens if you hit space? Good.
What I want.
What happens if you hit space again?
Oh,
I was like, hang on. In this case, actually, it's fine.
seems over it. Oh, off you go. Oh, we haven't removed the pending separation because it's not pending anymore. We've applied it.
Mm-hmm.
So we'll just do that.
Now, I was about to say there's a quick way of doing this, but it's actually not as quick necessarily. But what you're doing is fine. That's I'm going to keep going with your code, but we can talk about that.
Well, we'll learn a new thing as soon as I get it done. So that's maybe the end of that. Still not happening.
Well, it's kind of supposed to do that, recall. Because, yeah, it will always have to do multiple iterations with many circles. Just because of the way, I mean...
Oh, sure. Yeah, right. I was hoping to avoid that, but it kind of looks cool. But
Well, what you'd probably do is in the case where you could potentially track, for instance, how many iterations you would have to do. So you'd go through and be like, is there a scenario where something's got two overlaps like that? You know, do an extra couple of iterations when you hit space, and then it would just happen. And if you made it
simpler just to iterate until there are no separations pending.
yeah, pretty much. Or you could do that, or you could do it until like the magnitude of the separations goes to zero or close to zero, just so you don't, just so you're not like epsiloning it and having to, like, you'll see if I do that again, you've got like these tiny little wedges here, and then I'm going to separate again. I've still got another tiny little wedge. It's like at some point maybe we, like, I did another like 10 iterations and it finally properly separated.
Always a bigger fish. Everything is going to move for it. Yeah, it's kind of interesting to watch it kind of naturally try to find a place for everyone to go.
So
kind of cool.
If we were concerned about the number of iterations, like this case is going to be the unusual case, because you imagine if we've got a physics simulation and the chance of like three things colliding at the same time. First of all, they're not going to interpenetrate that much anyway. And then we separate them. Like they're going to bounce away from each other as soon as they collide anyway, so they're going to start moving away. So it's actually not such a huge deal. Because recall that one of the main reasons we're doing this is not so much, well, partly to separate it, but also to get the vector of impact, so we can apply physics.
That's right.
So, okay. Now there is a couple of things that we wanted to talk about this piece of code. First of all, let's think about how this is iterating, because, well, I can tell you one reason that it's taking longer than it should to separate. When we're going through here, where's my diagram? So you recall this diagram here. Let's ignore the fact that I screwed up the indices a bit, but what's the case where we actually do this? Yeah, okay, so over here, this is 0 versus 1, and over here, this is 1 versus 2. So we're actually touching 1 twice, once as I and once as j. So what's going to happen with this bit of code, we touch it twice, we've separated it from the one before it, but then we're about to separate it from one after it in the j section. This is going to be a problem because we're overriding some of the separation that's happening on that iteration.
Right. Okay. Well, is it enough just to perform it on I?
So, no, because, okay, so we have all this separation.
Right.
Ignore this code for now because we'll come to that. Actually, this code is actually fine too, but you recall what we were doing before was, whenever we do that, we'll go circles dot position plus equals, a move times n. You can imagine what this code does over several iterations. We're adding this one, and then we're adding this one. So in order to do that same thing, we actually have to do this. We have to actually accumulate the amount of separation.
Oh, that makes sense. Isn't that like D'Alembert's law or something? You have to apply everything to every, like, it'll work out if you apply all these multiple things to the same, like, place. It'll work out mathematically in the end. Something like that. I don't know. I'm talking out of my butt, but I guess it makes intuitive sense why you do that. You don't want to lose what you've already. You don't want to lose things. You don't want to lose pending movement that you've already captured.
Exactly. So we only want to be resetting it down here. So in theory, this should just work just fine, and now we've just got a minor code structure issue. So this should work a little bit better.
Yeah. That's clean. Yeah, in the case of just a few things that overlap, you get exactly what you'd expect.
Yeah.
I didn't like that, but
so that's just a side effect of the fact that it's separating from multiple things at once. So I mean, we can do something about that. So it depends. There's kind of a stylistic issue.
Okay.
Because you can imagine that. Where's the thing? Like this is how much separation we've got. So we're moving out that way, and then we're doing that there. So, and of course the arrows go away, but we're moving out that way as well. So we're separating by half of this amount and half of this amount, and we're separating by the addition of that. So really, it's probably easier if I just do this. Paste as. Okay, so this is one separation vector, and this is the other separation vector, and we're applying it to this circle. So we're getting that plus that. So the actual separation ends up being that, and it's that for all of them. So hopefully that makes sense why that ends up moving them all out. Basically.
Oh yeah, no, I get that. For some reason I just stylistically preferred that they would only separate the minimum amount as opposed, because we were been talking about the minimum separation.
Yes. So we might want to consider a system whereby that happens so that we can get closer to, the minimum separation between all three. One reason you might not want to do that is it involves more iterations, which maybe is something we want to avoid for performance. But if there's really a situation where we're trying to separate out the minimum amount, there's things we could do. For example, this addition here, where we're adding that vector and that vector, maybe we want to consider doing something other than addition, such that, for example, the magnitude of this vector doesn't exceed, say, I guess maybe I'd have to think more about how you'd actually do that, but basically you'd reduce the magnitude of this green vector such that it was maybe not exceeding the magnitude of, I think, the smallest of the vectors here. Basically, so you're not making that big jump.
Right. It sounds like it's not really relevant to learning here. So
No. So in this case, this is simple. This is easy enough for now, and basically what we're doing is, in theory, this should solve these cases in fewer iterations. Like that's solved now, sort of, more or less. And so you can imagine, like in a physics engine, each of these things making contact with another thing is going to not only have to do a separation, but it's going to do some physics simulation and stuff. And so it's actually better for us because after one iteration, all of a sudden, there's two collisions, and now there's none.
And it makes sense physically if you've got a whole bunch of masses occupying the same space, that it's going to be pretty explosive when it happens anyway.
That too. So yeah, that it doesn't really matter, but once we're doing the physics simulation, maybe that's a case that we care about and we'll think more about. But for now, this is fine.
Cool. You said there's a code situation, a cleanup to do here.
I was going to finish and say that the other thing you might consider is, which is actually what we did on River City Ransom, because it was possible to interpenetrate objects fairly easily for the player, and that is, in I'm not running it, in a situation like that, maybe we don't want to actually do separation. Maybe we just want the physics information, which is like this arrow here that tells us where they collided and how much they collided. Mm-hmm. Maybe we just want that, and we need to start using physics to, move them apart from each other. But we'll ignore the fact that they're colliding otherwise.
I see.
So that's another way of handling that situation. So you just never separate and just use it as a physics input. Anyway, so the minor coding issue here is, if we go through this, it's sort of the same thing as I was talking about before. We've got this situation here. We're touching, item 1 twice. We're touching it once as I and once as J. We're touching it twice because we're doing the same iteration. We're touching it twice here. So we touch it once when it's I, we apply the pending separation, and then we clear it. Then we touch it again when it's J, and it's 0 because we cleared it. So we actually can reduce this down to just that.
That makes perfect sense. Yeah, we have all the pending separations all in a nice contiguous line anyway, so there's no reason to use. Now that you say that, it seems obvious. Yeah, it's just an array. It's not anything special. Mm-hmm. To just go through it and apply the things and then clear them. Enough. So you said a better way of doing that than assigning vector 0,
yes.
Perhaps?
So, and it's kind of arguable whether it's a better way. It's more of a concern if you're like trying to multi-thread this, or, so you can imagine we've got, another thing going for, all of these circles, apply physics using the pending separation. Right. And in that case, you do these in multiple phases, then at the very end it's like, all right, now we clear it. That's just array dot, and this does a fast memory setting everything to 0. And so this might actually be faster. In the simple case, it's probably not that much faster.
Oh, that's the wrong one.
It is actually the right one. Although that's the right one.
Yeah, okay.
So I was like,
everything I know is wrong.
I thought you were about to do circles.length. And the thing is, we don't need to clear the ones we haven't used because we've never touched them, so it's always circles count.
Yeah, that's right.
And this literally does the same thing as this. Like that code and that code is equivalent, but this code is almost certainly going to be faster.
Of course, yeah.
Because it just goes in and just writes the memory rather than doing all the assignment and stuff.
Yep, that's cool. Of course, I've now forgotten. I've removed applying this.
I was like, hang on a second. And obviously, we probably want to clear it after we apply it rather than rather than before.
Tired. All right, there we go.
So the nice thing about structuring code like this is this can all be parallelized if we were so inclined. So this is getting into like harder core performance stuff. Say we had, thousands of these things we wanted to do. We can parallelize this because we are never writing to the circles array. And
that's right.
We are writing to this, so we'll have to segment this somehow. Because obviously, as I was saying, like in one iteration, you might be touching it there, and you might be touching it there, and you might be touching it multiple times. And if you split it up on multiple processes, we could be touching it multiple times. So you need to come up with a system for separating that. But this one is extremely parallelizable because you could wrap that in. What is it? I don't know what the library is for parallel for.
Parallel for each or for, yeah.
Have I even got that? Anyway.
Yeah, because that would be side effect free because every single one is independent.
Exactly. So.
Eminent parallelizable.
So this is a situation where maybe you do want to parallelize it, and then that runs a lot faster.
But
for now we don't care. But that's just a thing to think of in the back of your mind. Is like, what are we reading and what are we writing? There's another thing you might want to think about in this situation, and that is where are we touching memory, and in what order. So, for example, this is going to be very fast because it is blasting through two arrays. And it's not touching everything in an unfortunate way, I guess, which maybe we can talk about in the future. But I've talked about it a little bit before with you in River City, for example, about why you might want to access things linearly in an array for performance because of the CPU cache and the prefetch.
All right, cache coherency in the order.
Yep.
Operation of that. And
so you might find that's faster. And you might also find it's faster to read it all at once and then write it all rather than read, write. But that starts to get into stuff that you might want to measure and might not want to write in C# for that matter, if you're really caring about performance. For now, we've got however many circles we can draw, which is fewer than the CPU is going to care about. So I think... is that everything that we wanted to do today? We've got our separation method. It's working. It's doing what we expect. So you got to see that ping pong effect there, but that's fine. Cool. All right. Is that everything? I think that's everything.
Yeah, I'm good. I'm good there.
All right, sweet. All right, let's get rid of OBS and start recording. See you, internet.